Okay, let's do this. We're going super specific for this deep dive. We're looking at a piece of hardware that solves a huge logistics problem. The Thor Broadcast H-12HDMI-QAM-IPLL.
Right. And it sounds complicated, but think about walking into a big hotel or a hospital. You see all those custom channels on the TV, training videos, welcome messages, that kind of thing.
Yeah, you assume that's just a huge, messy stack of boxes somewhere in a back room.
It used to be.
Yeah.
And our mission today is to unpack how this one device is designed to replace all of that.
So we're basically dissecting a custom head-end system.
Exactly. It takes 12 different HDMI feeds and turns them into clean, reliable cable channels for an internal network.
And that kind of simplicity isn't cheap. I'm seeing it listed at just under $10,000.
Yeah, $9,995. That's actually down from an MSRP of almost 12 grand.
So the price tag isn't just about the number of inputs, it's about the versatility.
It's absolutely about the versatility. It was built for massive integration.
So let's start at the beginning. What goes in?
You get 12 HDMI inputs. You can run all 12 at the same time.
And crucially, I see it also has inputs for closed captions.
Yes, 12 of them, via a BNC interface. So right out of the box, you're compliant with accessibility rules. That's a major time saver for any administrator.
Okay, that's the input. Now, the real magic is what comes out, right?
This is where the engineering really shines. The primary output is DVB-C QAM.
Which, in simple terms, is how you get the signal onto a normal coax cable network.
Exactly. You're creating your own private, zero-subscription cable company inside your building. And you can map those 12 sources across 16 different channel groups.
But here's the part that I think is the real game changer for any modern facility, the IP output.
Oh, absolutely. So
Yeah.
at the same time it's sending the signal over the coax, it's also pushing out IP transport streams.
Over 2 separate gigabit Ethernet ports. I see it says 1 MPTS and 24 SPTS. Why do we care about SPTS? Break that down.
SPTS, or a single program transport stream, is all about efficiency. The main TVs in the hotel rooms might get the full cable feed. Fine. But maybe you have a digital sign in the lobby that only needs to show one specific channel.
So with SPTS, it can just pull that one stream over the IP network.
Exactly. You don't flood your network with unnecessary data. It's like a digital traffic cop.
Okay, that makes total sense. But what about, say, older buildings? A hospital wing with old standard def TVs right next to a new wing with 4K screens.
That's where the platform's internal processing really justifies the cost. It can encode in legacy MPEG-2 right alongside modern H.264. And more importantly, it has built-in HD to SD downscaling.
So you feed it a 1080i signal, and it can automatically spit out a 480p version for the older screens.
Yep. No need for a dozen external converter boxes. It's all handled inside the unit.
And you manage all of this through a web browser, right? A network management system.
Right. No more fiddling with tiny buttons on the front panels, all centralized digital control.
Which allows for some really broadcast-level adjustments.
That's the key. You get features that maintain the integrity of the stream, things like PID remapping.
Which is like changing the channel number so channel 5 always shows up as channel 5.
Precisely. And it also has accurate PCR adjusting, the precision clock reference.
Let me guess. That's for audio sync.
You got it. If that clock drifts even a tiny bit, you get that awful lip sync issue. This box keeps everything perfectly locked.
So, to wrap this up, what does this all mean for you, the person running the facility? This one device is the backbone. It lets you integrate 12 different video feeds into basically any distribution system you have, cable or IP.
And it replaces what used to be a huge, complicated, and unreliable rack of gear.
It simplifies everything.
Indeed. And, if we think bigger picture for a moment, this modulator supports global standards, DVB-C, DVB-T, ATSC, even ISDBT, which brings up a really interesting final thought. Considering all those different worldwide standards are packed into this one unit, what level of system planning would a huge multinational company need to do to leverage all of them at once, to create a truly seamless global internal broadcasting system from a single architecture? That, to me, is the real next frontier for this kind of technology.